Hello and welcome to today's monthly webinar entitled Learn How to Install Snowmelt Systems for Pavers. My name is Scott. I'm from WarmlyYours. What a coincidence. And the person I'm about to introduce you to is also from WarmlyYours. Who are we looking at here on screen?
Hi, I am Lynn. I'm a customer service rep, also oddly enough from WarmlyYours.
Well, thanks for joining us today, Lynn. And we're going to be talking about installing snowmelt systems under pavers and what that can do for you, and kind of give you a look at some one of the projects that's been done. So if you have any questions, feel free to click on the Ask a Question button there at the bottom of the screen, and we'll be glad to answer your questions as we go along. We do have a couple people that have sent in questions already. What I'm going to do is I'm going to save those till the end, because we're going to be covering them in the presentation, and by bringing them up at the end, we can then reinforce the point and make a better learning experience for everyone involved. So we have a couple questions, but feel free to ask your questions, because that's why we're here. So what's going to be covered in our webinar today, Lynn?
So today we're going to be discussing how the Snowmelt system is installed under pavers, kind of just some general information on the Snowmelt systems themselves and on the installation process, and then as well on the cost of installing a Snowmelt system like this, and some tips on doing the installation and running it.
Very good. So let's take a look at what's involved in these snow melting jobs. And I see a bunch of green here. What exactly are we seeing on our screen here?
So these are our actual snow melting heating elements. This is our snowmelt cable, the loose cable, and then the snowmelt mat, which is essentially the same thing. It's the cable itself, but it's actually on a mesh roll, so it can just be rolled out into whatever form you need it to be. So the snowmelt systems, really, they're designed to be embedded in concrete, asphalt, or in mortar or sand if you're using pavers. And these actually will really evenly heat the surface, so it'll melt the snow and ice.
Yeah, and
Sorry, go ahead.
No, that's right. These have to be installed under something that's going to be protecting them, something that's solid. So this is a type of product that you would never install under gravel. We get people asking us all the time, hey, can I use this under gravel? And the answer to that is no, because if you put it 3 inches under gravel and 7 years later your gravel's all worn away, you're going to be having exposed cables. So that is why you do not use these type of heating cables with gravel. So it's good to get that that bit of information out there for everyone. One thing to keep in mind is the snow melting mat is a little more expensive, simply because there's more materials involved in making it. You've got mesh, you've got tape, you've got the product to hold it in place. But what's so great about the snow melt mat is that the wires are pre-spaced for you at 3-inch spacing. So all you do is you roll it out, you cut the mesh, turn it to make it fill the spaces. It's really great for large rectangular areas. Now, if you're going to be using, if you want to heat circles, or if you have diagonal angles that are difficult to fill, or stairs, you will want the snowmelt cable. A lot of our jobs actually combine two of them. You can use a snowmelt cable in areas that are irregularly shaped and in stairs. Then you can use a snowmelt mat to fill the large areas that are rectangular that you want to do a quick install in. So that's why it comes in two different flavors. So let's take a look at this, and what do we have here, Lynn?
I'm just waiting for this to load. Give me a second. The screen... Are we on a different slide now, Scott, or is this the same slide?
This is Snowmelt for Pavers, and we've got the Paver showing up now. So I'll just go ahead and talk about what we see here while we're waiting for your page to load.
Yeah, I'm not seeing it on my screen.
We have the Pavers pictured here, and you can see that the Pavers are completely void of any snow or any ice. What happens is, when you are heating a paver like this, the best results you're going to be getting are from pavers that are less than 2.5 inches thick. The thicker you go with pavers, the longer it will take to heat, and it also can lead to unsatisfactory results if you get pavers that are really, really thick and a cable that's buried way deep in your installation. So it's very important to remember that the best results are going to be with pavers that are less than 2.5 inches thick. And also, we're going to be talking about the Snowmelt controls a little bit later, the controls that will allow you to have a nice clean surface like this instead of one that's filled with slush, or one that's filled with ice, or one that's filled with packed snow in between those gaps. So, Lynn, can you see our pavers in the picture now?
I can.
Okay. So we're sending our signal all the way around the world here. We have a bit of a delay, so I apologize for that. But let's go on to the paver cross sections. So Lynn, let me know when you're ready to hop in here to do this description. Otherwise, I will. Are you there?
I am. It seems like, there we go. Now I can see it. I can see the cross section. Perfect. So this is actually going to be, you're going to start with 4 to 8 inches of crushed gravel. You want to make sure that you're getting enough there to have a good base. And then you're going to lay out your frame. So you want to make sure that you're using something that's going to be pretty sturdy and hold up well. You don't want to use something like chicken wire. And then you're going to roll out your mat or lay out your cable, depending on how you are, what system you're using. Then you'll finish it off with some finished mortar, sand, or stone dust between 1 and 1.5 inches. And then you can lay your pavers right on top of that.
One question I got yesterday from somebody who was doing this exact install yesterday was they have the mat and they have the cable on the mesh, and they asked me if they could eliminate the 10 gauge wire fencing that we propose that they use on jobs like this. And I said, yeah, they can go ahead and skip that step because the cable will be held in place by the mesh. So what they can do is they can just lay out part of the mesh, cover it with the mortar or the sand dust, and work their way across. That mesh will hold it in place. However, with the cables, loose cable, you are not going to be able to skip the step of using the wire mesh. You need to have that wire mesh to tie the cables to. So very, very good cross section here to show you kind of the thicknesses and the layers that are involved in the installation. So it looks like we have a real live project here that somebody has done recently.
Yes, absolutely. We have some really great pictures of an example, or as examples of some of the of our project that just went down. I think it was just a few months ago, under a paver driveway and walkway.
Yeah, I can tell that it was done really recently because that installer is wearing a mask. So that's a dead giveaway that that's an installation from the summer of 2020.
Oh, yeah.
So let's take a look at the project overview. Tell us what was involved with this heating system. What did they get? Looks like this is like the electrical overview. This is great, and they obviously sent us a sketch of their area, and this is what they got back. So can you tell us what's on this page and what it's calling out?
Right, so it's going to show you exactly what mat you're using. It's using a 240 volt Snowmelt mat. It shows you the total dimensions of the whole area that they're heated, or the whole area that they're going to be installing in, and then the actual heated area itself. So that mat is covering 799 square feet. It'll also show you all their power requirements as well. So you can see the total wattage and amperage, and it'll show you a good breakdown of all the breakers that are required for this system, as well as the operating costs. You can really see exactly how much is going to cost you to run the system for an hour or 8 hours.
Yeah, so what is a good thing is we actually give an electrical plan with our installation plan, and that's something that the electrician can go out and start buying the GFEP circuit breakers, the breakers for the control, that sort of thing. The thing to keep in mind when you're doing outdoor heating is that the breakers need to be GFEP breakers, not GFI and not regular old breakers. You can use a regular old non-GFI breaker for the control circuit, which is actually powering the unit that turns everything on or off. But everything that's getting energized in the ground needs to be powered by a GFEP circuit breaker. So it's very, very important that you realize that it's not just a regular breaker and not a GFI breaker. GFI and GFEP are two different things. So when someone sends us in a plan, We then take those dimensions and we start filling that space with product that we have in stock. Why do we have these products already made, Lynn?
So that we can get them out to you right away, and so that they're very easy to see exactly how they're going to be laid out. We can tell you exactly what products you'll be purchasing and exactly how you're going to put them into the installation.
Yeah, so what happens is by having stock sizes, once we get the okay from you to place the order, we place the order and we ship it. You don't have to wait for it to be, we don't do custom lengths. We just do a product that is already designed, that we already have in stock, and then we take those stock sizes and design them to your space to make them fit. That way, you don't have to wait a month for these products to be custom made. We simply send you out the product that's custom that's made off the shelf with a custom design. So you can see that right here we have 6 of these rolls, and if you take a look here at the bottom, when you get your own plan, you will see that there is all kinds of good information down here, like the name of your job. It'll tell you once again what circuit breakers you need. It'll tell you what size rolls are included and how many. All that information is going to be here at the bottom. So this is what we call a smart plan, and smart plans are definitely the way to go, especially if you've never done an installation before, because instead of trying to figure it out all by yourself and go, gee, I wonder how many amps this is, or whoa, what's this going to be with wattage and all that other, we have it all figured out for you. There's no need to sit there and try to stress over, well, how am I going to design this? We design these every day. We do dozens of these every day. So we have a design team, that's their job, is just simply do these plans. So that's what's so great about these smart plans. So this is part of the job, and it looks like there is another part of the job. So what part is this?
So this is going to be the walkway that they have attached to the driveway. So again, you can really see exactly how all these pre-cut to length mats are going to be laid out. It's going to really show you exactly how to cut and turn it for even these kind of weird or different kinds of spaces.
Right, so here's the walkway. The walkways are usually very rectangular. Please keep in mind, though, where there is an area where there is no heating cable and there are pavers, these areas may not melt right away. The thing to keep in mind with electric heating is that the heat will only travel laterally about, with this type of product, probably an inch and a half, 2 inches away from the edge of the cable. So if you can't run a really small section right down the middle and expect it to melt the whole thing. So that's really, really important to keep in mind, because the most important application with that is knowing where there is no cable, there is not going to be any heat, is going to be stairs. And stairs are usually the area you want to make sure they're the clearest, because they're the most treacherous. You know, it can be difficult to go up and down stairs when it's snowy. So what's in this picture?
So this is showing how you would lay out the loose Snowmelt cable. So you can really see exactly the spacing. It actually indicates the spacing for the cable itself. And then those little red dots are also going to be the halfway mark for each of those cables. So you can get halfway through and make sure that everything is going exactly to spec without having to worry about, you know, finishing laying all of these cables out and realizing you have too much or too little.
Right. When you're doing a stairway, it's very important to get as many watts per square foot in that stairway as possible. And also, one thing I wanted to note on this drawing is if you know that you're going to be putting handrails in, you must let us know in advance, because we will design around the stairway, the handrails. That's the word I'm looking for, because the last thing you want to do is have somebody come in after the fact, after this is poured or after this has got pavers put over the top, and then start drilling holes in there to put handrails. So I don't know why I'm having trouble with that word today, but handrails, I'm going to remember that for the rest of my life, I think, from here on out. But the thing is, if you have some obstacle like that we need to design around, you need to let us know. So when you're submitting a plan for stairs, you need to let us know exactly how wide they are. You need to tell us how deep the stair is. That's called the tread. And then the riser is the part from where the tread is up to the next step. You need to let us know, is that 3 inches? Is it 5 inches? Because we need to figure the amount of cable it takes to get from there up to the stair on the next level. So that's why we use cable, because cable is much more easier to get into those spaces and start taking wire off of the mesh. You wouldn't be able to do this with the product on the mesh. It would be just too difficult. You'd end up taking all the cable off the mesh to put it into the stairs. So you might as well just get the cable as it is. So here we can see we have two cables. These triangles represent the start. So both of these cables will be starting right here. And then the triangles at the start, the rectangles or squares at the end. So you can see it starts over here and it ends over here. We always try to get the start points right by each other so you can get conduit to that spot and get those wires in that conduit then to a junction box. So that's stairs. We need to know the width. We need to know the depth of the stair. We need to know the number of stairs you have and the riser height. And that will allow us to get you the right quote of power in there, the right length of cables. Also take a note on this drawing. You can see there's a 4.5 here. If you have really good vision, that's the amount of distance from the cable to the edge. And you can see over here 1 3/4 inches. That's the space from the edge to the cable, because you don't want the cable hanging out the sides. You just can't do that. The cable has to be embedded and it has to be protected by the pavers. So here we can see the riser dimension, 12-inch riser. So also the distance from the front of the lip. One other thing before we leave stairs, stairs are so important. The reason why I'm harping on this is because we need to make sure that when you're designing stairs or you're installing cable, if you're not doing pavers and if you're doing like tile or something that has a bull nose that sticks out a couple inches, well, keep in mind that the heat only travels so far from the cable. So the further you go out from the edge of the stair with the bull nose, the further away you get, the more chance you have of getting ice there that won't melt. So when you're doing stairways, you want to minimize or eliminate the overhang, because overhang can lead to the front end freezing because air is getting at it from below, from the front, and from the top, and that makes that area that sticks out from the stair even colder than the rest of the stair is. So the best thing to do is to eliminate the overhang, and if you have to put a bull nose or something like that on there, minimize it, make it as little as possible, because the cable has to be within that front edge to get it to melt. So hopefully we remember that, and when you're designing your stairs, that's a very, very important point to remember. So this is my favorite part, but I'm going to let you take it from here, Lynn. What do we need to do before we even get started?
Absolutely. You want to make sure that you are testing the system before you even worry about doing installation. We always recommend testing the product as soon as you receive it from us, so that if there is any kind of issue, you are able to let us know and we can get a new product out to you right away. And then you'll also want to make sure that you are using a mega ohm meter. So you're going to test the system before, during, and after the installation. So when you're actually doing the installation, before you start it, we recommend testing it. Then during the installation, just keep testing it continually to make sure that there aren't any issues. And after the installation, before you power it on, we recommend making sure that after everything's finally completed, that you test it one more time. And you want to make sure that the ohms that you are testing and the ohms you're picking up are going to be within the margin that's listed on the product label, which will be actually on the cable or the mat.
Right, and this is not just a regular digital ohm meter. This is a mega ohm meter. This is an insulation tester, and this shoots 500 volts down the wire, and it tests to make sure that the insulation between the ground and the current carrying wires, it makes sure that the insulation between them is good and it won't cause a short or a GFI problem or a GFEP trip. So what you're doing with the mega ohm meter is you're actually sending a bunch of voltage down the wire, making sure that the wires that aren't supposed to touch each other are not touching each other. So if you don't have one of these, most electricians do have them. If you don't have one, you are going to need one for the installation. You can't do the installation without it. So make sure that you get one in advance, or your electrician has one. So let's talk about what we see in this picture.
So this is the gravel layer that we discussed earlier. We always say you should do 4 to 8 inches of that gravel underneath the mat. So here you can really see that they have it laid out incredibly evenly. You don't want any kind of, bumps in it or anything that's going to disrupt that mat. So you want to make sure that you spread that evenly beneath where you're going to have the snow melt mats or cable.
Right. That's absolutely right. You need to make sure if you get those two mats that are right next to each other, if you pull them apart, remember the heat only travels so far from the electric wire. So the further you pull them apart, the more you might have a chance for actually snow not melting between them. So that's why you can't just run a wire every 3 or 4 feet. It doesn't work that way. You need to make sure that the wires are evenly spaced and that the rolls are evenly spaced from each other. Just as the wires are 3-inch spacing between each other on the mat, you need to make sure that the mats are 3 inches away from each other too, because you've got a loop here and you've got a loop here. Those loops should be 3 inches away from each other. That's why you see a little bit of a gap here. That's that gap that is allowed for to make sure that you get that even heat spread. So let's take a look at what's going on here. We have lots of rolls going in, don't we?
We absolutely do. Again, as you saw earlier in the smart plan, you could see how all the rolls were laid out next to each other, and here's a really good demonstration of how that smart plan is now being put into practice in the real world. So you're going to lay them out exactly as designed, and they should be tested again at this stage. So using that mega ohm meter, you want to make sure that as you're rolling them out and getting that installation completed, you want to make sure that you are testing it again to make sure all those ohms are as they should be.
Yeah, you want to test it to make sure the ohms are good before you start putting sand or mortar and the pavers on top, because you need to know it now if there's something wrong. One thing that's also shown on this page is those black wires over here by the house. They are all there for a reason, because all these wires need to go to a junction box. These wires are only 20 feet long on this particular product, so you can't expect this product that's over here to have enough cold lead to run into the house. It's simply the cold lead is made long enough to get into a junction box. And whenever this wire needs to leave the heated area and go into a junction box, that cable, that non-heating lead, needs to be protected by conduit. The non-heating leads should never be open to air. They're either under the paver or they're in conduit on the way over to a junction box. So they're never exposed. The black wires here, obviously, if we put the junction box over in this corner, we can run the cold lead from this unit over to here, and this unit over to here, and this one, and so on. We may get to the point where 20 feet isn't long enough to get over here, so there's probably going to be a junction box put on the side closest to us also to allow these last 2 or 3 to get into that junction box. And then what happens is there's wiring, usually Romex or some sort of locally approved wire that gets from the junction box to the relay panel in the house. So the cold leads are only designed to get from the heating product over to that junction box. So we didn't really do an anatomy of the wire, but this wire that is green is the heating wire. Then there's a thick splice, and then there's a black cable. The black cable is a non-heating wire that's simply getting the power from the junction box over to the heater wires. And then the factory splice is where those wires are spliced together. That part heats up, so it cannot be in the conduit. It needs to be buried under the mortar or under the sand or something like that. And most local electric codes say that that splice cannot be within 6 inches of the tube for the conduit. So those are a couple of things you'll want to check with your local inspector to make sure that you're up to snuff on your code requirements. Remember, always install the product per your local electrical code. Your authority having jurisdiction will be the person to ask about that, and they will tell you, they'll probably come over for an inspection. So it's better to know this stuff in advance. If you have any questions, just let us know. Here are the junction boxes we were talking about. So what are all these wires coming out here willy-nilly?
So again, these are the cold leads that are actually going to be routed to the junction box. So again, you want to make sure that any kinds of splices or extensions that you're making in these cold leads are made in these junction boxes. So the cold leads are designed to be long enough to reach the junction box. You can usually see them on the actual smart plan that we send you. So we are aware that, we're making sure that we're getting that cold lead to the junction box itself. And then from there, that wire is going to go back to the relay in the house.
Right. So what's missing from this picture is the electrician doesn't have the supply conduit in yet. They're going to be drilling a hole in the side of this and then running a pipe over to the house in this direction. But this is he got this in right away so we could get the mats in at this point, and then he's going to get the hole drilled, get the conduit in the side of it, and get that wire from the house over to this spot to power that. So this is a great picture of what the junction boxes look like, and this is how they are installed, and this is what their job is. So now we've tested the cable, we've got the cold leads in a junction box. Now it's time to go to the beach.
Yeah, the beach that has mortar at it, potentially. So you're going to be laying out sand or mortar on top of that heating cable once it's all out. You're going to want to have 1 inch to 1.5 inches of that sand or mortar. You can use stone dust. It's just not as recommended. Sand or mortar is going to be the best way to go forward with that. And you're going to want to make sure that once you have that down, that you're going to allow the pavers to really settle into that surface without making sure that they're not actually touching the heating system at all. You want to make sure that heating system is completely embedded before putting any of the pavers down.
Right, and we had somebody called yesterday or the day before. Every day is the same here, but they called and said, "I need to use a vibrator to get those pavers down and set correctly in that." So they're going to be doing some impact on the top of those, and that's okay because the paver is resting in sand once again. It's not resting on the cable. So you need to make sure that you have at least 1.5 inches worth of sand there, that the cable is in the same layer as, because that way when you come by with the vibrator or the impact tool, that it actually rests in the sand, it compacts the sand or the stone dust and doesn't reach down to the cable itself. So now it looks like this is the pretty part taken over.
It is. They did a beautiful job with it. Once that is all completed and you're ready to start laying out your pavers, you're going to, again, very carefully, you want to be, careful not to have any kind of issues, but you're going to nestle those pavers into that sand or stone dust or mortar layer. Again, just focus on being really careful. If everything is gone according to plan, the cables will be completely embedded, completely covered, but you still want to just be a little bit careful when you're laying out those pavers. You want to make sure you're not going to be pinching them, or again, you don't want to ever have them be placed directly on those on the heating element itself. And then once you get all of that done and everything laid out, you can test it. No, go ahead.
So that the one thing I was going to say is, if you look at this picture really closely, this whole area is heated. You notice that you don't see the cable. The cable is not visible here. All you see is the sand layer. Very, very important that it looks like this when you're ready to set the pavers on top. So now we talked about the heating wire, the heating cables, the cold leads. We talked about the junction boxes. Now it's time to talk about how do we make this stuff turn on and turn off. The idea here is to keep homeowners going outside at 3 in the morning to manually turn a switch on or off to turn the unit on. Obviously, you want the system to be automatic and you want your controls to be indoors. So if you do want to manually turn them on or manually turn them off, you don't have to put on your galoshes and your snowsuit and walk out into the middle of the freezing night and turn this product on or off. So what do we have in this picture, and what do these things do?
So this is from the project that we've been showing you. They used our advanced snow and ice control. It does have a Snowmelt aerial sensor that actually gets attached. It's going to usually be somewhere on the roof line, somewhere that's unobstructed, so it can really pick up any precipitation that's coming down. It's going to pick up the temperature and make sure that the whole system gets turned on once it knows that there is something coming down from the sky and it's cold enough to be frozen onto whatever project you're working at. So it's going to that's what's going to completely automate it, make sure that it can turn itself on and off. And speaking of turning itself off, these controls do have a hold on feature. So it's actually going to continue to keep heating even once it detects that the snowfall has stopped. This way it doesn't turn into an ice rink. Once all that water is melted, you want to make sure that it doesn't refreeze by turning off the heating system right away. You want to let it all hold on, keep heating until all that water evaporates. So again, that aerial sensor is going to be really important for that. It's going to make sure to pick up any kind of falling or blowing snow when the temperature is below 38. And then once it sees that it's off, it's going to let the system finish its job and then turn it off completely.
Right. So what we see in this picture itself is we see the control, we see the timer on the front that we can set that hold on time. And sometimes you may need to turn it on for a little longer, maybe sometimes a little less, but there's also a little switch on the front here that you could turn it on manually or turn it off manually. If you know it's going to start snowing in an hour or in a few minutes, you can see it and you've got a report already that snow is starting, you can actually start the system early if you're there, and that way the system it's nice and warm when the snow starts to hit it. So you can actually start melting the snow right away. You don't have to wait for it to ramp up the temperature to actually do that. The sensor is simply, it has a interdigitated grid. I love saying that word on the top. And what that is simply a grid of two pieces of metal that don't touch each other, but and it's heated all the time. But when the snow hits it and that snow melts, that drip of water then makes a connection between the two grids, and that completes the circuit. And then there is a temperature, ambient temperature sensor sticking out of the bottom right here. If you can see that, that is what's telling it whether it's 38 degrees or above or 38 degrees or below. So the sensor says, all right, the grid is wet, and the sensor says it's below 38 degrees, so we're going to turn the system on. That's how it works. So if you have a job that has multiple mats or multiple cables, there's no way that this controller can control. You can't run all those wires back to the control. All of those wires go to this box. This box is the relay. This controller is like the front of your light switch. It turns on and off. And what it does, it turns on and off the relays that are inside this panel. So the breaker is sending power, circuit breakers, the bank of circuit breakers from your breaker box, sending power to this relay panel, and that power is always there. The controller then says, okay, turn on or turn off. When it turns on, all those relays close, and it sends the power out to the grid, out in the driveway or the patio or wherever it is. So this is simply a switch that turns on these controls, what they're the relays that are actually in there. So this is always getting power from the breaker box, and then this is always getting power from the breaker box on its own circuit. But then once the sensor says, hey, I see that it's cold and wet, this will go, okay, we're going to turn these on, and it'll send power to this box, and that box will click and you'll hear it, and all the power will go out into the ground. The one thing that we have here that we haven't talked about is this super groovy plaque that is solid brass, and it looks awesome. That is part of the National Electrical Code's requirements to make sure that it is signifying that this area that it's put in has an electric grid under it. So somebody doesn't come there with a jackhammer and start breaking it up. That's what this sign is. It's like, hey, be careful, there's electric wire under here. So that's what's going on in this picture. A lot of stuff going on, but boy, oh boy, does this look fantastic.
It does, and that's all those controls and everything are going to be so worth it when these homeowners are able to just wake up after a snowstorm and everything is heated and they're able to just walk right out of their house.
Yeah, this is a really, really interesting job. We can also assume that there's going to be cable under these. These are usually limestone caps. The limestone cap, remember, you want to get the wire as close to the front edge as you can to get that heat into the front. And then what I'm going to do is I'm going to click on this, and here we go. I'm going to see if this actually opens a new window. And yes, it does. So if you click on that, here's what's on our website, and you can take a look at some more all of our content is taken from here, but there's actually some more pictures that you can take a look at. And we have all of these kind of things under snow melting driveway showcases. So if you take a look at the breadcrumb up here, if you ever get to USA snow melting driveway example and showcases, you click on that and there'll be a list of these, and you can take a look at all these different applications. And here's more pictures than what we are showing, but it does show you all the information here. If you have an interesting project, you can share it with us too. There's a form there to fill that out. So there is that, and that is some super interesting stuff. So that's what the finished project looked like. If you want to see more finished projects, just go to our website, WarmlyYours.com, and we'll be glad to show you those too, because we love those things.
And another thing to keep in mind is that they did install this in the summer. So we know that, during the summertime, the last thing you want to be thinking about is the snow that's going to eventually be coming. However, you are going to want to install this while it's warm, so you're not out there freezing trying to get this in. It's a good time to think ahead and make sure that you're getting these systems installed so that when winter does come, you're prepared.
Right. So here is the list of the items that were included in this sale. So kind of break down what's going on here with this.
Yeah, so you can really see exactly what items they were using. So all those Snowmelt mats are the ones that they laid out. So you can see which mat exactly, the linear footage, or not the linear footage, rather the square footage of it, and the quantity of those mats along with the MSRP. You can see what controls were used. Again, that advanced snowmelt control with the snowmelt aerial sensor, and then all the accessories. So that's the snowmelt plaque that we showed earlier and the relay panel that would be inside the house. So again, all that is going to show you the line items, the quantity, the MSRP, and the total of that project.
Perfect. And a lot of people say, well, can I mount the relay panel outside? These relay panels are in NEMA 1 boxes, which means they are indoor only. So you want to make sure that your controller and your relay panels are inside, and that shouldn't be much of an issue because you're going to be supplying wire. The electrician is going to be supplying wire to get from those relays out to those junction boxes. So that's one thing to keep in mind. So what are some tips here that we need to remember when we're doing this installation so we don't run into any problems?
The most important tip is making sure, or one of the most important tips is making sure that you're not going to have that heating cable touching itself at any point. You don't want it crossing or overlapping. This can cause overheating, and then that can damage the system, which would require, or generally does require, replacement. That can be fixed, but it can just be also such a headache. You just want to make sure right from the bat, make sure that heating cable is not touching itself. You also want to make sure that once you receive that heating cable, the length of it should never, ever be cut or altered under any circumstances. You don't want to shorten it. Some people think that they can just order a whole bunch of it and cut it to size. You want to make sure that that's why you're using the smart plan. That's why we provide that to you so that you can see and make sure that you're getting the exact size and length that you need. Otherwise, if you do cut or shorten it, it can overheat it again, which does result in damage to that cable.
Right. And if somebody says, hey, I want to extend my cold leads, you do that in a junction box. You don't do it under the surface, because if that splice ever fails, then you're digging up your driveway. That's why you never do that. And it's also required by the National Electric Code to do that. So it's very, very important. If you are doing an installation and all of a sudden you've reached the end, and now you have 10 feet of cable sticking out, you can't just cut it off. We get this call all of the time. Hey, I've got extra cable. Can I cut it off? The answer to that is no. So what you do is you take off the last few runs that you've done of this, and then you go from 3-inch spacing to maybe 2.5-inch spacing to help you use that cable up. The minimum bend radius of the cable is 2.5 inches. So it can get within 2.5 inches of each other. It doesn't have to be 3. And if you live in an area that rarely gets snow, you can also do it possibly at 4-inch spacing. So if you're getting to the point where you're at the end of your installation, you have extra cable, lift up what you've done and get the spacing closer. You have to use that cable up. You can't cut it off at the end. So if you have a question, now's the perfect time to ask it. But we do have a couple of questions from people that have asked in advance. Do you have the questions there in front of you, Lynn? If not, I think I might have some.
I am pulling them up. I had them pulled up, and that was when my computer seemed to freak out on me. So I'm pulling them up now.
Okay, well, no need to. I will go. I did get them printed out, so I've got them here in front of me. So the first question was, how many inches on top of how many inches can go on top of the heating system? So we talked about that, right? Maximum layer thickness of the. Go ahead.
You don't want to have that over, I believe it's 2.5 inches, correct, Scott?
That right. 2.5 inches is your maximum thickness of your product. So what is the next question? Is that the cost per square foot?
Yes. So a typical Snowmelt system costs anywhere from $7 to $15 per square foot for the actual heating element itself. That's not including the control. And our control packages are anywhere from $525 to $2,799. So there's a vast range in there depending on the kind of system you're going to be installing and how you're going to be using it.
Right. You can. We have a Wi-Fi switch that you can use with an app on your phone to turn the product on or off. It's not automatic, so if you do turn it on, you want to make sure that you turn it off. Otherwise, it's going to stay on until it snows again. You're going to go, hey, I'm going to turn this on. It's like, oops, it's been on for the last month. We're going to see that in our electric bill. So we do have a Wi-Fi control. We also have a very simple timer. So if you are at home all the time, say if you're retired or one of you works and one of you doesn't, or someone's in the house that is always going to be there, you can actually use a timer. It's got a 12-inch timer, a 12-hour timer. So you can turn that timer on for however you want to and do it manually if you like. So we have all kinds of control possibilities, from the most manual, I'm going to turn it off and I'm going to turn it on, to the automatic where you never have to touch it at all. It does its business. It melts everything and you go, wow, this looks great. I didn't touch anything. This is fantastic. No ice, no salting, none of that. So it doesn't look like we have any questions, and those are the questions that we had supplied to us earlier by people that wanted those questions answered, and I think we did answer them. So let's go ahead and move on if we don't have any questions.
I believe so.
What's going on in our next webinar?
So our next webinar, I apologize, my screen is not pulling up that slide again. Do you mind telling them about that, Scott?
That's no problem. I've got it right here in front of me. Otherwise, I wouldn't have had it memorized. But what we have here is a webinar next month about how to find a repair and break in electric floor heating. So one common old wives' tale, for the lack of a better term, is that if something happens to your product in the floor, you have to rip up your entire floor and replace it. That is not the case. And also what's really cool is all the same ideas that you use to find and repair a problem in electric floor heat, you can also use to repair and find the problem outdoors in snow melting. I've actually myself gone out and repaired a couple of jobs under limestone caps. We've done it inside of asphalt. We've done it in stairs, on patios where they had drilled into the cable when they were putting lights in the really fancy house. They had lights actually up on one of the pads on the stairs, and unfortunately they got it a little too close to the cable. They drilled a hole and it went right into the cable, so we found it there. So that's going to be a great one. Join us next month for that interesting webinar on how to find and repair a break in electric floor heating, and it's always at 1 p.m. Central Time. You can also join us for daily trainings. We have daily trainings, and Lynn and myself and others do these, and they're every day, aren't they?
They are at least once a day. Sometimes we have them twice a day. Actually, more often than not now, we're offering them twice a day. So you can join us and just, it doesn't need, you can ask questions about anything. It doesn't need to be on that daily training topic. Just feel free to pop on in whenever you would like and ask away. We're always happy to chat with you about any of our products, about installation. Again, I know I do a lot of these daily trainings myself, and I am always very excited when someone comes asking questions about any of our products, because that's what we love to talk about.
Perfect. So we have some information here about our, I think I've clicked on the wrong one there. We're going to be talking about that, services. That's what they are. We offer Smart Fit, we offer Smart Guide, we offer Smart Install, we offer Smart Fix. We can do measuring for you. We can help you install it. We can guide you over the phone with video, like Zoom conferencing. We can do that too. And if you're local around the Chicagoland area, we can also come out and repair your product for you too. So let's talk about our monthly promotion. What is coming up this month?
Right now, for September, we are offering 20% off of our some of our towel warmers. So in the picture, there's our Riviera towel warmer. It's a really popular model, and you're going to be getting 20% off until the end of September. So it's a great time to buy. If you're interested in having warm towels, especially in the winter, it's a really great option.
Awesome. So we do value your feedback. You're going to receive an email shortly after this presentation. It's going to ask you whether you liked the presentation or not, if you liked us, and or if you didn't like us. But we also appreciate your comments and your suggestions. And also, we would love to hear what you want to talk about. It's much better for us to do webinars about information that you're looking for than it is for us to just pick one out of the sky and say, let's talk about this month. So please let us know what you would like us to discuss, and we will be glad to do that.
Absolutely.
They can contact us, can't they?
I believe they can. We have a couple different ways you can contact us. You can call us on the phone from 7:30 to 5:30 Central Time, Monday through Friday. We are here at the phones, ready to help you out any way we can. That number is 800-875-5285. Or you can email us if that's easier for you, or if you're interested in sending in a drawing you have for a smart plan. You can email either info@WarmlyYours.com, which is our general information box, and we'll get back to you right away. Or if you're interested, you can always chat with our president and owner, Julia. She loves talking with our customers one-on-one, making sure that you're getting all your questions answered and that you're satisfied with everything. So feel free to email Julia directly at jbillen@warmlyyours.com. Or you can go to our website anytime. It's warmlyyours.com, and we always let you know that's all spelled out. There are 2 Y's in that web address. Our website is a really, really great resource. It has every single product that we offer, has a full web page full of specs, frequently asked questions, pictures, videos, so you can really learn a lot about every product, and you can see installation videos, troubleshooting videos, blog posts showing previous projects, and just some really fun information on how others have used our products in the past. So it's a really great way to learn more about what we offer and what we can do for you. And then finally, we also have a Facebook you can visit. We do have all of our live daily trainings are broadcast there as well. You can also learn more about our monthly promotions and any new product launches that we have. You'll be the first to know when you're on our Facebook page.
Right. And please keep in mind that if you're in the middle of an installation and you have a question, it doesn't matter where or when you're in the middle of an installation, you say, boy, what is the answer to this question? I need to know how to wire this, or I need to how to lay this product out. If you're in the middle of an installation and you need help, you can always contact us 24/7 at 800-875-5285. We are available 24/7, 365. So please, 366 some years too. We're throwing in that extra day, no charge. So we'd like to thank you for joining us today. We'll be here again next month. We'll be here every day for you. So until the next time we see you, stay warm
and be radiant.
Bye, everybody.